Okay, in this lesson 4.6, we're going to continue proving triangles congruent, this time by using angle, side, angle, and angle, angle, side. Okay, so I think we need to just do a quick definition of included side and included side is the side connecting the vertices of two angles is the included side. So if I have two angles in the included side of one triangle congruent to two angles in the included side of a second triangle, then naturally the two triangles are congruent. So if angle A is congruent to angle D, side AC is congruent to side DF, angle C congruent to angle F, then triangle ABC is congruent to triangle DEF. And the other theorem is if we have two angles and the non-included side, one triangle congruent to two angles and the corresponding non-included side of the second triangle, then the two triangles are congruent. So in this case, A is congruent, angle A congruent to angle D, C congruent to F, and side BC congruent to EF, and triangle ABC is congruent to DEF. Pay attention about the order that this goes in. See, it goes angle, 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 side. Okay? Or it could go angle, angle, side the other way, going CA, side BA. Okay, continuous. Okay, so we're going to try and see if we can prove these triangles congruent and which theorem or postulate will we use. So looking at the first one, I can see I have angle, side, angle. The second one goes angle, angle, side. The third one, remember we always mark our congruence, and this is one from the last time. We have side, angle, side. This is a multiple choice question. Which postulate or theorem can you use to prove that ABC is congruent to DEF? Well, the only thing I have in this is the fact that they're both 90 degrees. I don't have a single side marked, and you can't prove anything congruent without having at least one side. Okay, so developing a little proof. Again, just like we've done in previous, I would mark drawings, and I've included the triangles for you. So DE with AB, angle D with angle A, and I want to use angle, angle, side. So I can't use B and E, or that would give me angle, side, angle, so I have to have F congruent to C. Again, mark your triangles. CB with FE, F with C, then what angle, side, angle? That means I need the side to be the included side. So that will give me E congruent to B. Okay, and again D, E, F, A, BC, ACDF, FC, and I want side, angle, side. So I need the angle to be the included angle this time. So the angle in between two sides would give me EF congruent to BC. Okay, so now this time we're going to mark our triangles. We're looking for J, K, L, R, S, T. So you mark them and determine if there is a theorem that you can use. So I'll mark them in a different color this time. So I have J with angle J with R, K with S, L with T. And that's angle, 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 and we don't have an angle, angle, angle theorem. JKRS, JR, LT. Now it doesn't go SAA, AAS. K, S, L. Oh, and that's a typo, and I marked the wrong one anyway. L, and this should be a T. K, L, S, T. Angle, side, angle. Okay, I have J with R, K, L, S, T. I only have a side and an angle, so I don't have enough info. All right, so I would try these on your own, see if you can determine if they are congruent triangles, and list the theorem of postulate. Remember, common side gets marked, vertical angles in the bow tie gets marked. Okay? So pause the video and try them, and then check your answers. So hopefully you were able to follow that. Please make sure you ask questions in class. This is the list of the theorems and postulates that we have learned. And just remember the order. Of the abbreviations. Is the same order. Corresponding parts must exist. Okay, and our question, if a side of one triangle is congruent to a side of another triangle, what information about the angles will allow you to prove the triangle is congruent? The triangles will be congruent. I'm sorry, I'm abbreviating. if the conditions of the ASA congruence postulate or the AAS congruence theorem are met. And this concludes the lesson.